Before we go deeper into the results and make decisions out of it, let's first meet our system, a brand new high-end washing machine, marked that it can handle any load effortlessly. It passed all internal tests, but we also need to understand what is a real world scenario and a lab scenario. First of all, let's start with our lab test. The machine was tested in the lab with the following properties: 1 to 2 t-shirts per cycle, perfect water pressure, ideal power supply, and no interruptions at all. So the results are 100% success rate, fast cycles, and zero errors. Here is where everything goes very, very wrong, because we make any assumption that it will work perfectly in the real world scenario. If we now go to the real world scenario, here we have a family of 5 people on a Monday morning, the laundry piled up over the weekend, different fabrics like jeans, towels, delicates, so multiple cycles back to back. Here the system meets the actual users. After a while, the first symptoms are shown like cycles take longer than expected, the machine vibrates more, there is even maybe an electrical outage, and the water drains slower. But everything still works most of the time. But let's discover the hidden problems and the main difference from the lab test and the real world scenario. There is a huge load increase, so there are more than 1 or 2 t-shirts per cycle. The behavior became more unpredictable, like let's say the external dependencies like the water flow, the drainage of the water, maybe even the electrical problems. This is never covered in the test during the lab test. One issue leads to another. Let's say that the water drowns slowly. It builds up, so the motor gets more stressed. Everything is shut down, and even maybe restarts are needed. If we bundle all this together in our findings, we will find that the machine only works up to 6 kilograms of load. Above 7 kilograms, it becomes very unstable. Thus, the drainage system becomes a bottleneck, and there is no protection against overload because we tested it. We put it in more than 7 kilograms, and everything went down. None of this was discovered during testing in the lab. If we now translate all this of the washing machine terminology into the system terms, like we use in IT, we have something like this. The washing machine is our application. In your case, it can be a web application or something else. The clothes are the user requests, and the water system are the dependencies like your database, maybe APIs, or even something else like I don't know. The drain is throughput. The drain is the throughput that handling everything. Like that, it's the same failures pattern, but in a different domain. If we talk about the results, we talk about most of the time about the average. People look at the average time, average speed, everything goes, but there things go badly wrong. If we look at average over test, everything looks pretty nice and satisfying. The test report says there is an average cycle time of 60 minutes, but in reality it shows that under heavy load it's even 95 minutes of cycle time. So everything's and some cycles even fail. The average hides the real problem. So if we want to take this in the lessons learned, it's better to use the 95 rule or even the 99 rule. The main difference between the 99 rule and the 59 rule is just the gap you use between those two numbers. The difference between the average cycle time and the 95 rule is that you use that you take off in the 95 rule. You take off the slowest times and the fastest times, and you compare them, and then you make an average of it. That's the main difference. So if we go back to the lab results, what did we miss during the lab test? There were no heavy loads on the system. We didn't try some spike scenarios where we put in some load and we put on again some extra load to see that the system can handle the extra load. We have no long running cycles because we are only washing one or two t-shirts at one cycle, so it's a short cycle. We didn't test any failures like the water drainage or maybe even an electrical fallout. That was not tested at all. We in the lab test we only simulated perfection, not the reality. So if we gonna take what we're gonna talk about now is what is a good test looks like. A good test looks like a different mix of load scenarios where you have some, let's say you have some cycles with two or three t-shirts, even with 5 kilograms of t-shirts, etc., or even different fabrics. The gradual and you want to test have a sudden load increase. So let's say you put in 2 kilograms uh, machine of laundry, and after that you put in some extra laundry. Let's say you put in an extra 2 kilograms. Then you have a sudden load increase. Your machine should still be working. Also, the continuous usage, because yeah, in a real world scenario, you don't gonna do one cycle at a day, but maybe multiple cycles. So you need to test the continuous usage of the machine, and even maybe simulate some drainage issues, like there is no the pipe is stuck with something messy in it, or something else, or maybe even an electrical fallout. You put on down the electrical and restart the machine. The washing cycle should continue. So in real life, we don't test the ideal world, but we test the mess. So if we talk now about the results and how does these results matter to make some good decisions, it's best to not just say all tests pass to your stakeholders, but more talk about system supports X, loads safely, it breaks at load Y, and the Z component fails first. If we look at the washing machine, the Z component it's our drainage system. If we talk about some IT infrastructure, it can be your database or even your API call that is not responding very well. So now we have a decent report with the correct conclusions. We can make some decisions based on our findings. So if we talk about good results, you can say it's safe to launch for production, but it needs scaling before we go into campaign saying that it can handle any load effortlessly. It will fail under some peak load. If you put on more than 7 kilograms, the machine will fail. That is the real goal of testing. So to end this brown bag, I want to give you some takeaway. You wouldn't certify a washing machine by washing one sock in perfect conditions. So why do we certify systems that way?